All the homies, they know what I mean. Baby, let me show you how I live.
Hillary, this movie is really boring. Do you want to go play Xbox?
No,
Do you want to go eat some food?
I do not.
Do you want to go on a roller coaster?
Nope.
What about go to Starbucks?
Nope.
Oh, jeez. Do you want to go talk about the physics of outdoor activities?
Yes!
When Sarah and Hillary jump up and down on a trampoline as seen here, the force of gravity pulls them towards the earth and they make contact with the trampoline. The elasticity of the trampoline, combined with the coiled springs connecting it to the frame, absorb their impact and store their force. Because the trampoline gives and allows for a greater time in changing velocity than solid ground, impact with the trampoline seems softer and is much less harmful to your joints. The stored force in the trampoline and springs is released when they compress back together, transferring the force to Sarah and Hillary, shooting them back up. Now normally with a dry trampoline, the coefficient of friction is high enough between Sarah and Hillary's feet and the trampoline material to maintain stability. However, the rain on the trampoline lowers the coefficient of friction, making it harder not to fall.
Oh man, I'm so tired. What do you want to do, Hillary? You want to go fishing? No. Let's go fishing. I just said no. Come on. Yeah. Let's do this. Yeah! Yeah!
Waves created on top of the water from the lure are both transverse and longitudinal waves. These are called surface waves. Because the surface waves are composed of transverse waves, they exhibit some of the same characteristics as waves that we've learned about in physics, like those from the electromagnetic spectrum. For example, if a small lure is used, its impact with the water will create water waves with a low amplitude, which is similar to a weak signal AM radio wave. Increasing the size of the lure will increase the amplitude of the water wave, which can now be compared to a strong signal AM radio wave.
Let's do some yard work. Oh yeah!
We're just chilling here in Josh's backyard, doing some yard work, which should help us have a better understanding of physics. Firstly, Josh will use an axe to split wood. When splitting wood, Josh does not want to provide excess force to the downward motion of the axe. This will result in an inaccurate swing.
Oh, darn it!
Instead, Josh should only provide enough force to lift the axe to its peak height and have the force of gravity take over from there. Josh will demonstrate the chopping motion now. Okay. As you can see, allowing the force of gravity to control the acceleration of the axe results in a better cut. What about the two pieces of wood that are created from the cut? With our knowledge of physics, it's easy to see that these pieces of wood behave as projectiles when they are launched horizontally from the chopping block. Once the axe provides an initial horizontal velocity to the wood, that velocity stays constant through its flight. Additionally, the only vertical acceleration felt by the wood is due to gravity pulling it towards Earth at 9.8 meters per second squared. If we take the change in height between the chopping block and where the wood projectile lands, we can calculate the time it's spent airborne using the formula time equals the square root of 2 change in d over acceleration due to gravity. Hey Josh.
Yeah?
Since we're done chopping wood, can we go use the chainsaw?
Sure, but before we use it, let's explain how the centrifugal clutch in the chainsaw works.
Oh.
A centrifugal clutch in a chainsaw works like this. These weights are connected to compressed springs on an axle that turns as the engine turns. So as long as the engine's running, this is going to be turning. However, when the engine is idling or not being accelerated by the operator, The springs hold the weights close and they do not engage with this outer cover, so this will be turning and turning, but it will not engage with this. When the operator increases the speed of the engine, the velocity of the weights increases, and the tension on the springs increases, which spreads them out, engaging with the outer cover. And now this entire assembly will rotate as a whole, which is connected to the chain, which will turn the chain.
Isn't that kind of like what happens in a merry-go-round?
Why, yes, Sarah, it is. Imagine yourself as a person on a merry-go-round. As the merry-go-round spins faster, you feel more of a pull towards the outside of the merry-go-round, and if it spins fast enough, you will fly off in the direction you are currently traveling, or tangent to it. This same effect is felt by the weights in the centrifugal clutch. However, it is not centrifugal force. It is instead inertia, which comes from Newton's first law that objects tend to stay at a constant velocity, both in magnitude and direction, unless acted on by an outside force. Your velocity on a merry-go-round is always tangent to that certain point on the circle you're at, and centripetal force is responsible for pulling your body around the curved path that you travel on. Because of this, you feel the pull towards the outside of the circle. Centrifugal clutches undergo the same process, and the properties of inertia and centripetal force can be observed, except that instead of people, weights are used. And now we can see the centrifugal clutch in action. And there you have it, that's your centrifugal clutch. Well, that was a fun day.
Yeah. Want to see what's on TV?
Sure.
Like a cholo. Laid back, bounce in the car. When we do a dance, so we do it like what? Like a cholo.
Side to side, elbows up, side to side, elbows up, side to side, elbows up, side to side.
Like a cholo.